Hi, it's Robin. Recently I did a video about a Lodestar toolbox that used SYS commands like SYS and some address, and then adding a comma and some parameters. You could use variables like X, Y, or the width or the height of a window or whatever. And there were some questions about how that's possible to extend the SYS command that calls machine language. So I thought I'd do a video about how that's possible in your own machine language programs to read parameters from BASIC. It's actually fairly easy. Sorry if this episode sounds different. I actually forgot my good microphone at my friend Darren's place while we were recording our podcast. So I'm just going with the camera mic today. So we're going to be using Turbo Macro Pro. Just looking at the directory here, we can we'll load up Turbo Macro Pro, comma 8, comma 1. So a D64 will be available in the video description for you to download if you want to try this yourself. The TMP file is the assembler that just runs on a stock C64. Temp plus RU is the RAM expansion unit version, which is more powerful, but we don't need it today. And once the assembler is loaded, it's just SYS 32768. Okay, and as of the time I'm recording this, the latest version, just type back arrow L. The latest version of the source code is ML10. But you can check the directory. In case I find a bug, I'll update that file. So just look at the directory and load the file with the largest revision number. Here is the source file. And we're going to take a walk through it, but first we'll just run it to see what it does. Just go back arrow 3 to assemble it. I just press back arrow to get back to the editor. Back arrow 1 to exit out to BASIC. And SYS 828, I've assembled it to the cassette buffer, which is a convenient place for a small routine. You could do it elsewhere if you like. And what this routine is a memory fill routine. So you give it the starting address, and we're going to do screen memory starting at the second row, which is 1024 is this top corner. I just want to fill screen memory by using this routine. So 1064 is starting right here, 40 characters along. And then the number of bytes we want to fill, and it does take a 16-bit address. So we'll do 400 bytes, just a multiple of 40 will make it easy to see. And the character that we want to fill memory with, in this case, I'm going to put 1, which is the character A. And I'll press return, and it should fill 10 lines of the screen in an instant. There we go. Now you'll note that the screen filled in the light blue color instead of white. That's because we haven't actually filled color memory. So we could actually do that. And instead of 1064, we could do 55296, which is color RAM. And we'll add 40, just so it's that same section of screen. It should turn all those A's white. And there we go. Of course, the basic prompt is printed on top of that, but anyway. So this is a general purpose memory fill routine, which might be handy for BASIC, but it's just an example here. And it could be used to fill any area of memory, but the screen memory or color RAM is a frequent place that you'd want to fill. And in BASIC, that's normally very slow. Like to do the equivalent in BASIC, it would be for X equals 1064 to 1064 plus 400, actually plus 399, poke X, comma, and some value. We'll put 2 in for a B. And next, just watch how much slower this is. Oh, sorry about that. We'll just do new, which is required when the basic one here just get messed up sometimes. Here we go again. You see how that took a few seconds. Well, up here we could fill, I can change it all to the letter C, screen code 3, instantly. Oh, I changed color memory. Okay, So let's take a walk through the code. So here is the origin where the program is going to assemble to. Like I said, this is the cassette buffer. When we're using Turbo Macro Pro without the RAM expansion unit, we're limited in where we can assemble to because the assembler starts at about 8,000 hex, 32768 decimal, and uses all memory above that. And in fact, if you look down at the bottom of the screen below the cursor, it says B:$7EBC. That's the BOM of memory. Source code starts just below 8,000 hex and works its way down. So we can only assemble to that area below. If you use the RAM expansion unit version, you can assemble anywhere in memory actually. Okay, and then we've defined some 0-page locations. I just realized I'm not needing this variable anymore. So now I'm going to save this as ML11. Here you go. Now you're seeing me update it as we go. I was using 5 0-page locations, but I decided that that extra value one is no longer needed. So here we go. These are two 16-bit addresses. I should actually add that as well. You guys are my rubber duck. Okay, so these are the 4 addresses we're using. This is the address that the fill starts at. And then these 2 bytes are the length. And we'll see more about that in a moment. And then here are 3 basic ROM routines that we're going to use to read those SYS parameters. These routines are part of BASIC, and normally they're called by BASIC to read the parameters that you type in, like a poke command or whatever. But they can also be used to add your own parameters to a SYS command. So that's what we're going to be doing today. So one is the skip comma routine that looks for a comma delimiting the parameters and skips ahead. Then one, this eval parameter that evaluates a parameter and even lets you use variables, not just constant numbers. So it's really quite powerful. And then a routine that converts from the normal floating point value that eval param receives and converts it into an unsigned 16-bit value that's easy for us to deal with in our machine language program. So here's the actual beginning of our assembly language program. First, we're going to call a routine called read parameter. And all it does is calls these routines. We'll look at that in a moment. And it returns in the Y register the low byte of the address that we're going to write to, and in the accumulator, the high byte. And we're just going to store those in 0-page because we're going to need them in a moment. We'll just skip down to that read parameter routine. And it really is that simple. It's just calling those 3 basic routines to skip the comma in the command, evaluate the parameter, and then converting it to a 16-bit unsigned value that's returned in the A and Y registers, and returns. So the first parameter is the address that we want the memory fill to begin at. Next, we're going to get the length, the number of bytes to fill. And I believe that has to be at least 1 and a maximum of 65535. If you give it invalid parameters, well, if you give it 0, I don't think I actually tested that. Don't call that if you want to use 0. I haven't done much error checking on this. I guess it could be made more robust, but I don't know. We're directly filling memory. This is dangerous stuff anyway. Commodore Basic, like, is it worth the extra code and like the extra bytes spent, the extra cycles burned on good parameter checking? I don't know. You can decide that. I don't think it is worth it. If you make an error, it's probably going to be disastrous anyway. Okay, so it reads the length, and then finally it's going to read the value that we want stored in screen memory. That's actually just an 8-bit value, but we're still just going to call the same read parameter, but we're going to ignore what comes back in the A register. Normally up here, that's where the high byte comes back. We're just ignoring it, and we're going to move whatever comes back in Y, the low byte, and move it into A. And that's what we're going to be storing in memory. So that's just when we typed a screen code of like 1 for A, it comes back in Y, we transfer the Y to the A. Now we're going to set up for the actual fill. We've already got all our parameters ready. The Y index is what we're going to be using for indirect indexing. So we just initialize that to 0. It's just going to be a loop to store the bytes. Then we load the X register with the high byte of the length. I'm using X just because it's not doing anything else here. We're not even going to use it again, but this is a way of checking, is the high byte of the length 0? If so, then we have 255 or less bytes, and we're going to jump ahead to this remain routine that cleans up the remainder of the bytes that's handled at the end. So basically that's just checking, are we filling less than a full page, less than 256 bytes at a time? Then we're going to just branch ahead to the remainder routine that we'll look at in a moment. If not, we're going to go and execute this, and we're going to be filling full 256 byte pages first. So we're all set up already. The accumulator already has the screen code, and we're going to store that indirect indexing in whatever address is pointed at. So in our case, that would be like 1024 decimal 0400 hex if we're filling all of screen memory. And adding the Y register as an offset, we're able to fill a 256 byte range with one loop here. And we just increment Y, and if it's not equal to 0, just branch back to the loop. So it's just a very tight loop, as fast as the 6510 can go. That's not completely true. If we weren't using indirect indexing, it could be faster. But this is the fastest we can do while using indirect indexing. And this is the standard way of filling RAM, unless you need absolute performance where you would unroll or use self-modifying code. We're not doing that today. We're going to advance address to the next page, and we do that just by incrementing the high byte, address +1. So if we did all of 0400 to 04FF, this would then increment that 04 to 05, so it's pointing to the next page, which is the next group of 256 bytes. Then we're going to decrement the high byte of the remaining length. So if we were trying to copy 4 pages, that would reduce it to 3, to 2, to 1. And if we're not at 0, now after the decrement, we check branch if not equal 0 back up to loop 1, because we still have more full pages remaining. But if we're done filling full pages, then we just go down to this remain routine here, and we're nearly done already. So like I wrote in the comment, fill remaining bytes. So it's going to load the Y register with the low byte of the length that's remaining. And here's a special case. I had a bug here that I had to handle. If Y is, we've just loaded Y, so it sets the 0 flag if it's equal 0. Branch if equal 0 to done. If we copied exactly 100 hex bytes, then it's already copied one full page. The remainder would be 0, and we have to check for that before we do another copy, or else it will accidentally copy a full extra page. So we branch if it's equal to done. Otherwise, we decrement Y first, then we store the fill byte in addy, Y in the address, just like before, and branch if not equal You see, store A does not change the status register. We've done a decrement. That is what has affected the 0 bit here. So the reason we're doing this is because we've handled all full pages, so we must have FF or less bytes to fill. So by decrementing first, we're making sure that if we decrement to 0, that we still do fill that location, and then we branch only if we're not 0. If we are at 0, we're done. Those last bytes are getting copied from the top down, and we're doing that instead of going up, we're going down so that we can have this tighter loop. It's just more efficient this way. And finally, we're done. And there's the read parameter. Okay, so again, we'll just assemble it here. Back arrow 1 to drop out to basic. Changing the cursor color to white and clearing the screen. Okay, so we can use this in a short program. For example, 10 for x equals 1 to 1000, 20, and we'll call the fill routine, and we're going to do it to screen memory again, 1024, top left corner of the screen, and we're going to fill it with x bytes, and we're just going to fill it with x as the screen code. Now notice that even though the screen code will be a value greater than 255, that is, it'll be 9 or 10 bits long, the routine is just going to ignore that high byte and basically mod 256 or and 255. That is, it'll just truncate any extra bits, and it just will only use an 8-bit value for the screen code. So this is just an easy way for us to fill the screen with a variety of characters. 30, next. Okay, and let's try running this program. And this might look a little bit glitchy, so if you're affected by flashy visuals, you might not want to watch this. Run. Okay, so there it is. You can see that it is filling memory. And you can see it's smoothly incrementing and the whole screen is full. So it's a pretty good test to show that the routine is working as expected. And there is some error checking built in just because of how Commodore BASIC processes these commands. It's basically for free. If I list the program, if I forgot to add a parameter, for example, so say I only added 2, we'll run it. You see it returns a syntax error. And also note how it is processing variables. It's meaning it doesn't only accept constants, but it will also accept variables or even expressions. If instead we wanted to offset the value, we could even include some math. And I don't know, just 1 byte. And again, we'll use X just so that the character changes each turn. So this should create a different kind of display. There, it's filling memory with 1 byte each with an increasing character. It's really quite elegant. A lot of power for such a short program. Just to re-enter it there. But really, that is not a whole lot of code considering how much we could extend BASIC right there with a variety of sys commands. Okay, I hope that was helpful. Thank you very much to my patrons for your support. I will probably be getting back to some book club videos in future months. Okay, thanks again, and we'll talk to you later.
up in the projects, went to school every day, ran home as fast as he could, only had 30 minutes to play. One TV shared by a family of 6, he'd hook up to his VIC-20, quickly type in his latest game,